Hey guys, how's it going? Hope you guys are having an awesome day. So today we're going to be doing the nucleotide count in Go. So in our last episode, we did the isogram code that's over here. So, we did the isogram code over here, but this time we're going to be doing another easy one. So we're going to be doing the nucleotide count in Go. So you could just pause the video and go over the introduction. So given a single-stranded DNA string, we need to figure out how many times that nucleotide occurs in that string. So it will give us a string that consists of A, C, G, and T, and we need to just figure out how many times each letter has occurred in that given string. So here is an analogy. The problem also wants us to define a custom type DNA with a function counts that outputs two values. So the frequency of the given DNA strand and an error if there are invalid nucleotides. So only if it's A, C, G, and T will that string be valid. If it does not have A, C, G, and T, then we have to return a false. So let's just quickly get into it. So first, let's just download this problem so we can copy it over here. And then go to our terminal over here so we could just copy paste it. And there you go. Now we have the nucleotide count right over here. Yep. And this is our main nucleotide count.go. Before that, let's just get rid of our old isograms. And here you go. Okay, so this time they did give us a function to work with, and they gave us two types. Okay, so we also need to choose a suitable data type for histogram and for DNA. Okay, so let's just get into it. We can first go to cases test.go and just see what it needs. So it looks like our test cases are all nicely defined like this. This is our histogram. So it looks like our histogram is gonna be of this type. So it looks like either a string and a int map or a byte. Looks like a byte. So we can just fill that in. So in our histogram, we can just turn this into a map with byte and int. So I've done this because if you go to casestest.go, they've actually defined their histogram over here. So we can see that this is a map, and the map is going to have its key as a byte, which is over here, and it's going to have a number over here. That's why in our nucleotide count.go, I have declared it like this. So this is going to be our data type for histogram. Now for DNA. So over here it says DNA is a list of nucleotides. We could see over here that in our counts function, we are getting this D as type DNA. So if we go to casestest.go, yep. So strand is basically gonna be the string that is sent to us from our test cases. So I think DNA is supposed to be a string, so we can just turn this into a string. Awesome. Now over here, we could see that, okay, we need to return a histogram and an error. So error, just in case the string that is passed to us does not have the valid nucleotides. So just to recap, we can only have A, C, G, and T. These are our valid nucleotides. If it's anything beyond this, then it's not acceptable, and we have to return an error, because over here we need to return an error if this is not a valid strand. So over here, they're declaring H as a histogram. So what we would need to do to return a histogram, we need to tell the program that what the valid nucleotides are. So we can probably do that by manipulating H like this. We could just declare this as a histogram, and since it can only have A, C, G, and T, we can just put it over here. I'll explain in a sec why I am declaring it like this. So A, C, G, and let's do this, and then I can just put the 0 like this. Awesome. So the reason I've done this is we're going to write our logic such that when we're going through each letter in the strand, if the letter is not A, C, G, or T, then we could just check it against our base histogram that we are supposed to return. And if ACG, and if the letter is not ACG or T, then we could just return a error. Oh, since we are going to be returning an error, we should probably import errors as well. So we can use errors. We can import errors like this and manually generate our errors. So with this, we can even return like custom error messages, and it's pretty cool. So over here, let's just go through each byte in our DNA strand that they send us. So just to recap, they're gonna send us strands like this. So this is gonna be a strand. Since it's just G, we need to just append one over here because G occurred only once over here. Over here, there are no like nucleotides, so all of those counts were 0. Over here, G occurred like 7 times, so all the other nucleotides are 0, but G is 7. Similarly for this thing. And yep, this is a invalid nucleotide, so we could see like X is not going to be a valid nucleotide because we just want A, C, G, and T. So yeah, it is gonna expect that we give it an error. So let's just code this in. So we could just run a for loop to go through each nucleotide that is in our DNA. And so in this for loop, what I've done is I'm just going through each nucleotide that was sent to this DNA like we did in our previous isogram program. And we don't really want the index, so we're just gonna not initialize a variable for it, but we do need the nucleotide. So we're gonna compare the nucleotide to ACG or T in our H histogram, and if it is there, then we're just gonna append these values. So we're just gonna append these values, but if they're not, then we're gonna return an error. So if score OK is equal to H by nucleotide, then we can, if it is found, then we can just add 1 to the count. Oops. So there you go, nucleotide, and just add 1 to it. So over here, what's happening is we're checking if the nucleotide, so like each letter inside this DNA, if it is part of this H histogram. So what we're doing is we're converting it to a byte, the nucleotide into a byte, because all of these are bytes. I'm pretty sure they're gonna be ruins. So once they're turned into bytes, we're just gonna try to put it in H. So H is like a map over here. So we're just gonna try to retrieve its value. So this if statement, this is supposed to be the value. So, but we don't need the value. We just want to see if the value exists inside our H histogram that we will be returning with all the counts. If it is there, then OK will be set to true. And because we were able to find that nucleotide inside this H histogram, we're just gonna add 1 to the count over here. So over here we're actually going to use the nucleotide and actually take out its count value. So H byte nucleotide is gonna get us these values over here that's next to these nucleotides. So suppose nucleotide inside the DNA, suppose we're going through the loop and we find a G, then we're gonna be putting G over here inside this histogram, and it's gonna go over here. So it's basically like a hash map. So we were directly able to jump to this thing's value, which is 0, and we're just gonna add 1 to it. So if you know how hash maps work, this is basically what we're doing here. We're just taking the nucleotide value from the DNA over here and then just plugging it into the hash map over here and then just retrieving its value. Once we retrieve the value, we're just gonna append it by 1 because we were able to find that nucleotide inside the DNA. So what if this was not true? What if the nucleotide was not in this hash map? Well, if it was not in the hash map, then we should return an error. So we can just do that over here. So if nucleotide, so suppose this is an X. If this was an X, it's not going to be in this histogram. So OK is going to return a false. So, and once it does return a false, then this else statement is going to be run. So we could just return H because over here we have to return H. So what's happening over here is it will accept the DNA, this function, but whenever it's returning, so this is the part that we're telling Go that we need to return values. So over here, EXERCISM basically wants us to return a histogram type, which is this. We're going to be returning these and an error. So if we don't find the error, suppose the DNA is perfectly valid, then it's not even going to go to this else statement. It's just going to go here. So over here, the return will be nil and we'll be returning the histogram. But if we do get an error, we could just return out of here. So we could just write errors.new. And we could just type in any error message. So this is how you use errors. So over here, we're gonna raise an error and we can put any message we want to. It really doesn't matter to EXERCISM, but we can put like a general error message like error happened, I guess. And there you go. Our program is done. So what we can do is we can run our tests. Go gives us, not Go, EXERCISM gives us an option of testing our benchmarks. So in the nucleotide program, we could just run this. Let me just copy this and run it over here. No test files. Oh, not in the nucleotide folder. There you go. Let me just clean this up. There you go. So now what's happening is we're passing everything, no errors, which is exactly what we wanted. So just to recap, so let's just recap really quickly because we have the test over here as well. So just to make sure I'm not jumping between screens, you can just see empty strand, can count 1 nucleotide in single character input. These are basically the descriptions that come with the test cases. So over here, empty strand, can count 1 nucleotide in single character input, the same thing. So what's happening over here is in the first one, we just sent our program empty strand because it doesn't have anything we expect this to be returned. So ACGD counts should be 0, which we are returning. So yep, because there's nothing, it didn't get any letters over here, and it just returned this histogram, which is perfectly valid. And for this case, it was a G, so we looped over everything and just got a G. We just plugged in G in our map over here and got the 0 value, and then we just appended this over here, the G0, and this turned into G1. And as we could see, yep, it expected G1 over here. Similarly for the other ones, so G 7 times, we appended it like 7 times, and this came like this. Same for this. Over here, this is a little different. So we weren't able to find X. So when X was plugged into here, sorry, not here, here, it wasn't able to find it in H histogram because as you can see, there is no X here. So because it wasn't able to find X in this, in H, OK was actually equal to false, and because this was false, we used the else statement instead of the if condition. So in Go, you can include a condition as well as initializations in if statements. So this is what we did here. We were we could have initialized this, so this could have been the actual value. So in this case, it would have been 0 if nucleotide was G. So we could have had this value, but we didn't really need this value, so we just left it as blank. But we did need OK. OK we needed to test our condition. So this OK we basically needed for this if statement. If we were able to find the nucleotide inside H, we would just run this if condition. If we were not able to, then we would run this else condition, which was basically returning errors. So now we can just remove these comments, we don't need them. And that is our program done for nucleotide. So let's just upload this quickly to EXERCISM. So EXERCISM gives us a command to submit this, so we can just do EXERCISM submit and then the path to file. Let me just copy this, EXERCISM submit, and then we can submit our nucleotide program. .go. There you go. And now we have this link over here. We could just take this link and see our solution over here. There you go. So this is our solution that we coded up, and it's over here. So awesome. We completed the nucleotide program in Go. So thank you guys for watching. If you enjoyed the content, make sure to subscribe and click that like button. It really helps out the channel. And yeah, I hope to see you in the next episode. Have a good one. Bye.